So, yes, you're right. It would be 4 times the limit as theta approaches 0 of sine of 4 theta divided by 4 theta. We just learned that this is 1. So bring down the 4. That's 4 times that, which is 4. Okay, the next one, this is all about manipulation.
Would we multiply by 3 on the top and 2 on the bottom? No, we couldn't do that.
Well, one thing we can do is, since this 3 is not in a sign or anything, I can pull it out in front. So I can make that 1/3 times the limit as x approaches 0 of the sine of 2x over x. I could do that because 3x wasn't with a sine or cosine or any other trig function. So I just moved that 3 out in front. It was on the bottom, so it stays on the bottom. Now I have this 2 here. So what do I need down here?
2.
Another 2, yeah. So if I just put a 2 in here, let me change the color. All right, boy. If I just put a 2, so that means I'm dividing by 2, right?
You'd have to divide by 2 on that side.
That means I would have to multiply by 2, because you want it to equal 1. So if you divided by 2 and multiplied by 2, that's the same as multiplying by 1, or dividing by 1. So it's really just a 2 up there then. Question, Faith?
But that wouldn't equal 2. 2/3.
2/3, what about it?
It wouldn't equal 2, would it?
Oh, it does. Well, it does, because what I'm doing is I'm multiplying that by 2.
Oh, you're multiplying numerator. That's the right term, right?
So we end up with 2/3 times, what should this be?
1.
The answer is 2/3. Number 4, let's see if you can manipulate that one.
Dear Lord.
Dear Lord is right. Got 3s and 5s and just stuff going everywhere. Ah!
They're literally all prime.
So my dog stuck his head in the euphonium.
That is the greatest thing I've
And of course, my son took that opportunity to go. It was awesome.
I mean, we got a Dr. Pepper stuck in the sousaphone. That was like my freshman year too. It was pretty bad because you don't want to tell Miss J because then we would get in trouble.
No.
So in the middle of a band meeting, all the band kids are in the band room screaming, trying to get this Dr. Pepper out of the sousaphone. Like, we had tongs, like we were like blowing on. We had to get Levi McGrew to stick his hand down it and grab it, and he barely got it out. And when he got it out, everyone started screaming. The kid who got stuck like got on his knees. He was so happy.
Did Miss J ever find out?
No.
Oh,
I got
awesome.
it stuck.
Matt Carter.
I need to stick a Dr. Pepper in that.
I had no clue, but he apparently put
Well,
it in there and it got stuck.
why does anybody do anything, really?
See, I wasn't in there for it getting stuck.
And those instruments are like super expensive too.
Oh yeah.
Not that all of them aren't, but those like
Like
sousaphone,
the
tuba.
bigger ones? Yeah.
do we get that 2?
That 2 we can just move out in front.
Oh.
Okay, that's what I did.
Yeah, because that's just 2 times sign. So we can just move that. That's not right. I just need another one of these.
So you just move them all out.
Now you can move the 3 though, because it's not
We
with the
can't
sign.
move the 5. Oh, yeah.
You'll have to put the 5 in there. You'll have to add the, or
Can we do
multiply.
like a 5th?
Yeah.
Like 1/5?
Absolutely.
That's what I want to do.
Yeah, in under here. Yeah, you put that here.
Yeah.
I keep forgetting you can't see where I'm pointing.
No.
We'd have to multiply by 1/5 or by 5 on the outside.
Yes.
So we get 5, 6. Wait.
5, 6.
No.
Whoa.
Yeah.
I
Because
think,
you'd have to divide by that 2.
I think
Okay, you're not dividing by that 2. That 2 I just moved.
Oh, you can just,
Yeah, I can just move that because it's not with the sign.
we do like 3/5.
And that 3 I can just move. The problem is I need a 5 now on bottom. So I can just put that 5 there, but that's a divide by 5. So that means I have to multiply by 5.
so 10 thirds.
There you go. So that's 10 thirds times 1. We good? All right. So this one, didn't even have a sign or anything. So if I plug in 0, yeah, it didn't work. You know it's not going to
Are
work.
we going to do the trig identity thing?
Yeah. So what trig identity?
I have no clue.
Sine over cosine.
Yes. You would rewrite tangent as sine over cosine. And I still have 1 times theta here. Okay, so how can I rearrange that? Because it's still not going to help me right now. I still have 0 over 0.
Oh, wait. Oh, no. Like 1 minus cosine theta?
No, I can't subtract it the way it is, but I can rearrange it. So that maybe not the cosine theta, can I rearrange it to maybe look like this stuff?
Yeah. Butterfly.
That's what I was thinking.
No, butterfly is if you're adding or subtracting. When you're multiplying, they just go together.
Oh, so the cosine square
So what I can do is I can just put sine of theta over theta. I can just move that over there. And then just leave 1 over cosine of theta over here. That means the same thing. I've just rearranged it. Because if I'm multiplying, I multiply these 2 together and these 2 together.
So wait, is it secant theta?
Well, you don't want to do that.
Well, because the sine would be 1, which is...
Right. So this is 1.
Yeah.
And then we just figure out this one.
Well, that thing isn't equivalent to secant?
It is. Or just figure out what the cosine of 0 is.
1.
1.
Yeah.
Yeah.
So we already did.
So it's 1 times 1. All that for a 1.
Oh, wait. You want me to use that circle thing, didn't you?
I did
You
use
did
that
circle.
circle thing.
Oh, I didn't.
You used the calculator? Oh!
I could forget.
No!
She's gonna attack you.
In case I forget to tell you, you should be able to do a lot, if not all of day 6 homework.
Yay.
Okay, number 6. Now, this looks like these are ones where we do the cosine thing. Yes, ma'am.
Ashley just asked me to ask you how to find the absolute value on our calculator.
Absolutely. Oh, it's go to the math button.
Yeah.
You see it?
Yeah.
And the cursor to number, N-U-M.
Yeah.
And then it's like the first one maybe. It says
Okay.
abs.
Okay.
Okay. So what can I do up top here? By the way, if I put in 0, I get 0 over 0.
Fun.
Well, would you use the calculator?
No calculator. What can I do on top? Factor out of 2. Very good one. 1 minus cosine squared theta. 1 minus cosine squared theta should ring a bell. It's sine squared of theta. The trig identity, that's right. Okay. Now we have a rule that not sine squared of theta over theta, but what is it? Sine of theta over theta. So I can separate that out.
Oh.
That limit goes with both of those. So the limit of this one I know is 1. What's the limit as theta approaches 0 of the sine of theta?
What?
Oh, let's look.
It's 0.
Here it is.
Cosine's 1 and that's 0.
Yeah, it's 1, 0. Sine is the x coordinate, so it's 0.
Wait,
X
sine's the
is
X.
Y.
Oh, I pointed to y, but I said x.
Yeah.
So it'd be
It's
0.
still 0.
It is
Right.
0.
Okay.
What time is it?
Close to time.
Oh.
Okay, on number 7. I'm going to separate it into 2 things that I'm adding together. Yes.
That's 0.
Close, yeah. I have 1 minus cosine of theta over theta. That's the part that you're thinking is 0, right?
Yeah.
And then I have plus sine of 2 theta over theta. This is not a problem. It's 0.
Yeah. Fine.
The other one has a little problem.
We have to get 2 on the bottom.
Yeah. So what do we do?
Multiply.
By 1/2.
Yeah, put a 2 down here and multiply by 2.
No. Oh. Yes.
So it wouldn't affect the whole thing?
No, only that side where you're adding it.
Okay.
Good question. So this then is 1 times 2. Then 0 plus 2 is 2. And we'll stop there. Don't forget, day 6 homework and a quiz tomorrow.